Welcome to this course on design of machine elements. You know, today we are going to give you the introductory lecture on design philosophy, that is the lecture number 1. Now, before starting this particular course, let me tell you a few words that this course is primarily an elementary level course on the design, and for this course the prerequisite is only, you can say, the ideas what you have already gathered from the basic course on strength of material and engineering mechanics. The knowledge of these two courses what you have already covered, I suppose, will be enough to follow this course. And once again welcoming you to this course, let us proceed for the lecture number 1 on design philosophy. Firstly, what we understand by the design, or what we are going to do in the design course, or what will be our objective to take and design as a whole, let us have some discussion on to it. So, first of all, if you look onto this board, you can see we have given 3 points: basic concept of design in general, concept of machine design and their types, factors to be considered in machine design. So, all these 3 points are, you can say, an overall idea that which will give us a guideline to follow a machine design or design of machine elements as a whole. Now, you can just see that design is essentially a decision making process, and we can see that for every problem we need to design a solution, and so that if we combine together, then what is happening? The design is to formulate a plan to satisfy a particular need and to create something with a physical reality. So, just looking through just the 3 points that what I have just told you, let us have ideas that what is being meant by these 3 typical points. It is a decision making process. The most vital part of our design is a decision making process, and everything is pivoted on the decision. So, one designer should be a good decision maker. That is one of the primary objectives in the design. Now, once again you have seen that what we have been talking about, that for every problem we need to have a solution. That is what is being meant to that one. In the typical type of design, or whatever you find out in your practical day to day life, when you face a problem, then you have to solve it. You may not be knowing many things for the problem. That what you will do? You will try to solve your problem, building up your ideas onto the existing methodologies or existing whatever you are having in hand. You cannot simply sit idle looking for the fact that I will gather all the knowledge, everything, and then I will give a solution. That is not a very good design concept. The idea is that the world will go on running, but you have to give some solution which is feasible, which is applicable and which will be used in the mankind. Yes, of course, you can have continuous changes over that, continuous modification over that, but something you have to give. So, with the existing knowledge, whatever you are having the tools in your hand, make a decision, and that decision is what is the primary objective of a machine design. That means, what we once again, if we try to formulate the entire idea, then what we can say, just have a look once again, that design is to formulate a plan to satisfy a particular need and to create something with a physical reality. Now, I suppose you have understood that what I have just meant to say about this design ideas, that means a concept or whatever you say, that why the decision making is important. Let us go for another example. Say we take up a example of design of a chair. It is a very common thing you have seen in everyday life. A design of that same chair, the responsibility is given to you. Then what you should look into the fact. Here the factors need to be considered, comes out to be like something like this: the purpose for which the chair is to be designed, whether the chair is to be designed for a grown up person or a child, material for the chair, strength and cost need to be determined, aesthetics of the designed chair. So, let us take up those points one by one. First of all, the factors to be considered is for what the chair is required. Is it a easy chair? Is it a chair used for study purpose? Is it a chair used in restaurants or dining tables? So, one has to know, that means one has to define the problem. So, you know what is the for the chair is being made. If it is an easy chair, then you understand that its backrests, its hand rests will be designed accordingly. And if it is a restaurant chair, hand rests may not be there, because the size of the chair should not be that big and it has to fit within the small tables. At the same time, is the chair required for an old person or a child? Then you understand that depending upon the situations, your chair design also changes, the size will change, okay? The color look might be changing, that will come down later on in this design of chair. Now, again you know, normally the material of the chair is wooden. Well, you can have the chair made of aluminum, you can make the chair of wrought iron, which are very common nowadays. So, where it comes in consideration is aluminum, wood or wrought iron is not the problem. The problem is that the material, or the problem in the sense what I mean to say, the thinking in the line should be like this: the material should withstand the load of the person sitting on the chair, whether he is an old person or a child. Here the material selections is one of the very primary thing in the design aspect. First of all, the material should, as I told you, should take up the load, that means it should not fail. Another thing is that it should not be too costly. Another thing that by making the chair by that material, the chair should not be too heavy, so that it cannot be carried from one place to another place easily. Hence, we can see that in the design, just simply for consideration of the chair, one has to think of these things, that failure, that means material selection should be such that it should not fail, it should not be too costly, and it should not be also heavy too. So, this is one of the aspects of the material. You can understand in any other designs, this is also a requirement. Now, you can see that we have been discussing about that aesthetic sense. Now, what is the aesthetic sense, you understand? That means just 4 legs, 1 backrest. Suppose you have designed the chair, simply having 4 legs, 1 backrest and 1 handrest, without any shape or not looking very, very attractive. Now, the word attractive is a relative matter, I understand, but overall you have to look into the fact. That means, what is the fact? That overall how the people's mind are there, what we understand, what is beauty, what is the color concept, which colors are being preferred by old man, which colors are being preferred by children, which color suits in the restaurant, which color suits in a home dining hall, or which color suits in the seminar hall of an institute. So, there comes an aesthetics part in designing the same chair what we have been talking about. Similarly, another aspect of the design of chair has not been pointed out over here is also the ergonomics. You understand the ergonomics of a chair means it has to have a standard height, it has to be having a standard width or depth, whatever we call, or in other words, in short, I may say that the dimensions of the chair has to be like that, that it can, suppose you have designed for an old man, then it can accommodate an average variety of old man in general. Means a person having an height of say 5 feet should not feel uncomfortable. At the same time, a person having an height of 6 feet also should not also be comfortable in the similar manner. So, somewhere you have to put the ergonomics into account. If I can say roughly you measure all the chairs, you will be finding out that in general the study chairs or the restaurant chairs will have a height of around say 18 inches, 16 to 18 inches in general. All the reading tables, study tables, if you try to find out the heights, then you will be finding out that it will be in the vicinity of 30 inches. So, this is an ergonomic aspect, that if it is like that, you will be feeling comfortable while working. So, you can just see in this particular example, we have taken up so many aspects. Just simply a design of a chair has to be thought very carefully, looking into some of the ideas just which came into my mind right now. However, if you go through a more thinking process, you should add more to what I have said, so that the design is good, your decision comes out to be much better than what the decision I have taken. So, this is one of the aspects of what I was just considering in the design of chair. So, what we understand as a whole, that almost everyone is involved in design in one way or the other in our daily lives, because problems are posed and they need to be solved. So, every walk of life, in each and every walk of life, it is a problem, is a design. You are designing, continuously you are designing. Your mother at home is cooking, she is designing. She is designing new recipes, and her decision of course we know is very good, so you relish the foods. So, that is a design. So, every day we have the problems and we need to solve it. You go to the market, you want to buy some copies, pencils. That is a design, that is a decision making, which one will be better to suit you, suit your requirement. That is also a design. However, once we see that almost everyone is involved in design, we get an overall idea is that what we mean by design. So, once again the design or the basic concepts of design comes into the factor is the decision making, every stage of design, consideration of different factors to draw certain conclusions leading to an optimum design, market survey to read people's mind, study of existing norms. All this taken together, you can see all this taken together are again reiterated in decision making every stage of design. Means you take this one, think of over, go to again and decision making procedure. Once you are finalized all these ideas together, then you come to an conclusion, again the same decision making, which is the basis of the design, and that is what we call the basic concept of design. You understand a bad decision leads to a bad design and a bad product. That is what is the gist of taking a bad decision, as you have seen here. Say for example, you can see there could be two cars available in the market, of course on the same size, same range, are doing the more or less the same type of work. So, do you think that one is bad, one other is good? Both are doing nicely in the market, both are being used by the people. So, what the situation is coming out to be? Some decision was there that both the designers for the cars have thought of, taken the decision, and then they have optimized the design and given a shape to their ideas. Now, one of the important factor in their design or the decision making, what I have just shown you, is a market survey. That is also another category of design, we will be just looking after a few minutes. That type of designs are very much dependent on market survey, people's mind. That is also a very useful in decision making. Once you have taken a decision, then rest is relatively easy. Suppose you have chosen that for this category of car, my engine size will be such that it is creating a 60 bhp. Whatsoever may be the other cars available in the market, that is also 60 bhp, theirs is also 60 bhp, yours design also 60 bhp, it does not matter. You have taken a decision and you have launched your product, and they have taken a decision, they have launched your product, both are going parallelly. Now, the difference may be there in their sellability, because someone might have taken a better decision while implementing the design, looking into people's mind and looking and reading the people's mind for one of them could be better. So, his car might be selling little fairly than the other one. So, all this leads to a single point. What I was trying to say is the repeatedly I am telling the design is a decision making. Again we look to the other one, is that the design disciplines. So, design may be of different products and with present specialization and knowledge bank, we have a long list of design disciplines. Say to pick a few: ship design, clothing, fashion design, which is very common in today's life, you can see, process design, building design, bridge design, and many more. And lastly, we concentrate on our machine design or design of machine elements, as the quote suggests. Anyway, the overall we call it as a machine design. Now, you have seen so many disciplines of the design. Every field, whatever has been shown in the slide, are based upon certain knowledges acquired by the people in that particular discipline, and they have taken some decisions from their knowledge of their discipline and are designing the required products in their specialization. Say cloth design. So they know the people's mind in a similar manner what has been discussed. There is no point in repeating, and from that people are doing the cloth design, someone is doing the ship design. Now here we are for the machine design. So what we understand by the machine design? Now just to know about machine design, one has to know what is machine. First of all, one has to know what is machine. Let us look onto a definition of a machine as a whole. So as I have given over here is a idea of the definition of machine. Machine is defined as a combination of resisting bodies with successfully constrained relative motions, which is used to transform other forms of energy into mechanical energy or transmit and modify available energy to do some useful work. Now, here you can see that we have defined in this second paragraph, the machines can receive mechanical energy and modify it so that a specific task is carried out. So, you see that the machine definition lies in the fact that we are, in general, we are getting some sort of energy at the input device, and then we are getting some useful mechanical works. In that particular process, the transformations are being done by various machine elements, which are put together in a combination in a coherent manner in such a way that one machine element responds nicely with the other machine element, and thereby creating the ultimate effect in the terms of some mechanical work done in general. So, that is what we understand as a machine. Now, so what we understand, once again, just you can look at that particular slide where it has been given in the form of a picture which says a modification transformation of energy. That is what I told you, utilize the machine elements. So, that means this machine elements is our primary duty, which has to be designed. So, machine design involves primarily designing machine elements so that they may transmit the forces and perform their task successfully. So, this energy what you get, you use some machine elements, and then and these machine elements will give you the output in terms of mechanical work done. Now, that is the idea of the machine design as it is being written here. So, before we go to this particular aspects of machine design once again, let us have a look at something else. Now, we can see that Here you can see a person riding a cycle. So, we can think of that he is giving some sort of energy, and just take a look at this one. If you are giving some sort of energy, and you can see the pedal which is transforming the energy to give you a rotation of the cycle, and that is the output work he is getting. That means, this is one machine design problem. Here what you are getting, that the energy, a mechanical energy being transformed to another form of mechanical energy, and as far as the design is concerned, what you will be getting, that you have to design the pedal, you have to design the chain sprocket arrangement, you have designed the wheel, you have to design the bearings, so that your specific problem of moving a person through a machine which rotates and moves onto the road. Well, this is what is our problem, which in one term we call as a bicycle. So, this is one example of what we can say, a mechanical energy is being transformed to a mechanical energy. So, this is a simple situation all of you know, and these all are machine elements. Here you can see a aircraft. This aircraft was used in 1971 in Bangladesh war. So, this is also a machine, and primarily this machine runs on fuel, aviation fuel. So, the aviation fuel is being utilized primarily to give you a mechanical output in terms of flying the aircraft. This one you can see is a locomotive engine. Nowadays is not in operation. However, it has got very interesting machine elements. So, that we will come to see. So, here also you are using combustion, coal combustion to make a steam, just coal combustion to make a steam, and that steam, you know, through a steam chest, it is giving a reciprocating motion to a piston arrangement, and that piston, while reciprocating, giving a circular motion. You can see very carefully that this piston coming out, these are the links which creating the reciprocating motion to a circular motion in the wheel. These are all what you can see the machine element. Okay, so we have a look onto this one. So, this is another example that all the machine is being, and see a synchronous coordination, what was just telling, that this machine element is coordinating with this machine element, and gradually you are getting one from one form of the energy. I am just pointing out this form of energy, because this is I suppose that is a steam energy you are getting, and then we are getting a mechanical work output in forms of rotation of the wheels. These are the different machine elements. So, the entire one is a machine, however, these are machine elements. So, that was shown in the definition, that how we can, what is the idea or what is the definition of the machine as a whole. So, just have a very quick look onto that one. Yes, it is a closer look at the machine elements. Well, here you can see a car of the same ideas. That means you are using an fuel to drive a car, and these are some of the internal components of the car. So, you understand that this is the air filter, this is a battery for giving you the, this is a source of power, and some few more we can see. Well, this is a very close look. This is I think it is from the back side, and it is a radiator, and so and so forth. All the other components. This is the main engine. Well, just missed it. Okay, this is the portion where we have seen the engine. You have also seen earlier. A closer looks to some other units. This is a belt drive. You can see here. This is a belt drive. It is a mechanical drive, and so this machine is also built up of so many machine elements. So once again we can see how nicely the machine elements are being synchronized to perform a operation, and that entire one we call as an machine, and you are going to design such machine elements and put it together to form a machine. Well, once again this is the filters, oil filters. This is a close look at the battery. See, here is an arrangement where you can see a rotary, yes, see, a rotary motion is being giving an reciprocating motion. See, this is the inner crank is giving an rotary motion, and outer side. See, this is the slot onto which this bar is moving, and this is another link which is actually rotating this link, as you can see in the figure. It need not to be described, all the things. Here is the lathe machine, what you can see, we have seen in our workshop. This is a machine, and interestingly at this moment the specimen it is making, or the job it is making, is a specimen for tensile test. Okay, specimen for tensile test. So this particular lathe is driving power and electrical power. So the transformation of electrical energy to a mechanical form. So these are few of the machine elements that what we have seen. So that gives you the idea. Okay, so we have seen, once again just quickly look at the board. I mean this one, machine design involves primarily designing machine elements so that they may transmit the forces and perform their task successfully. So after looking at this particular video clips, now you got the idea. That means what we meant by machine elements, how it is transmitting the forces to perform the task successfully. What are the successful tasks we have seen? A bicycle, aeroplane, car, etc. So this is the concept of the machine as a whole, and we are now clear what we are going to design. So once we see that we are defined that our job, that what we are going to design, that is a design of machine elements. Now we come down to the idea that the types of design. What are the types of design we can see? One is an adaptive design, another is developmental design, and another one we call as a new design. So, these are the types of design one can think of. Let us have a quick look at what we mean by these terms adaptive design, developmental design and new design. Now, adaptive design is based on existing design. Standard products or systems are adopted for a new application. Conveyor belts, control systems of machines and mechanisms or haulage systems are some of the examples where existing design systems are adopted for a particular use. So, basic thing is that let us discuss on this particular point, that what do we mean by adaptive design now. So, adaptive design is, just we have seen the definition, something is available, you put it together and let it perform its duty, it is an adaptive design. Say you have got a pump purchased, you want to run the pump to lift water. You require to rotate, run the pump. How you run the pump? Obviously, if you are having an electrical power with you, let us assume you have an electrical power with you. So, you utilize an electrical prime mover. Now, this electrical prime mover has to be attached to the pump shaft, so that the pump shaft rotates, it rotates the impeller and your purpose of lifting water is being satisfied. In this particular case, how you are joining these two ideas, how you are transmitting the power, it could be directly coupled. So, you have to design a couple, we will be learning later on how to design a couple. Or you have seen a belt drive, just now what we have seen in the car in the video clip. So, similar a belt drive is required to run the pump. So, you can do in either way, either you use a coupling or you use a belt drive. Now, interestingly, the pump, the motor, the belt or the coupling, everything is available, it is standardized. So, what you do? You just put it together to solve your purpose. Although the designs of examples of conveyor belt, haulage systems etc. are given over here, I am giving you another example, just what I have cited right now. This is what we call as an adaptive design. The next one in the line is the developmental design. Now, this developmental design is something that existing design is there and you are going on developing or modifying the design. So, new model of a car is a typical example of a developmental design. At the very the onset of this lecture, I was telling that you have to give a solution to the world, you have given it. Later on you thought that moment the decision what was you have taken was correct, but it could have been better if I have considered certain other aspects. There is an ample opportunity to do that, and that is what we understand as a developmental design. So, you go on developing the design and get a newer and better products. The last one is a new design. Let's have a look into this one. This type of design is an entirely new one, but based on existing scientific principle. That means, you are not creating any innovations, okay, it is given later. No scientific invention is involved, but requires creative thinking to solve a problem. Examples of this type of design may include a small vehicle for transportation of men and material on board a ship or in a desert. Some research activity may be necessary. So, what we understand by the new design, that is the product is not available in the market, but there is a possibility that if you can look or if you can design something like that, it might helpful to the mankind as a whole, people as a whole, like that. So, you go on thinking, give some innovative ideas, and for which you are not creating a Newton's law, means a new invention, but what is exactly you are having in your hand, the tools, you are utilizing that. However, whether your ideas are crystallizing or not, you can have some tests on models, you can make some research activities, and that is where you have seen the scope of R&Ds in the industries and many other places. So, here is the idea of the new design, something which is not exactly existing, you can think of that one with available ideas, knowledges, and your innovative thinking and some research activities. So, this is what we understand by new design. Now, we can see the design when we classify the types of design based on methodologies. Earlier we talked about what could be the types of designs, and this is what is the method based designs, means what are the methods by which we do a design problem. Here you can see we have given 3 such sets of ideas. One is rational design, another is empirical design, and another one is, the third one is industrial design. Let us have a look once again that what we understand by these 3 terminologies, namely rational design, empirical design and industrial design. Rational design based on determining the stresses and strains of components and thereby deciding their dimensions. What it is meant by the standard design methodologies, or overall what you have learned so far in your earlier strength of material, I can say that is one of the examples of a rational design. How? You know stress is how much? Stress is defined by load divided by the area. So, you have some load onto a, say, a circular rod, and then having a cross sectional area, say A. So, you know that P divided by A is a stress generated. Now, you do a tensile test for that material, find out its yield point, means the point where the material is going to fail. Say this value is sigma, the value is sigma. So, sigma equals to, so if we look into this one, then we find that what we understand, that is this, excuse me, so we, what I was trying to say, sigma equals to P divided by area. So, what you understand is that if you know the load, if you know the design strength or the material properties, so area comes out to be P divided by sigma. This is your design. That means, what should be the cross sectional area, you can immediately tell, provided you know the material property. So, that is what we are trying to say about this, that based on it, this is the one Yes, this is the based on the this is the rational design slide. Sorry, it went to other slides. Anyway, now come down to the industrial design. Industrial design is based on industrial considerations and norms, that is the market survey, external look, production facilities, low cost, use of existing standard products. This we have already discussed earlier in some other form, that while designing a market survey, there is people's mind, what should be the external look, which people want more, okay, what could be the production facilities that will make my product cheaper. All these considerations are the what we understand by industrial design. Of course, this design is based on existing standard products, no doubt, but you have to have an extensive knowledge base for all these ideas of the market, production facilities, newer developments in production technologies, and the primarily the cost factor. So, these are all what we understand by the industrial design. Now, the another one, the last one is an empirical design. This is based on empirical formulae, which in turn is based on experience and experiments. Here is a typical example what we can cite. When we tighten a nut on a bolt, the force exerted or the stresses induced is very difficult to find out, that is exactly, but experience shows that the tightening force may be given by P equals to 248 D, where D is the bolt diameter in millimeters and P is the applied force in kg. Here is surprisingly there is no mathematical backing of this equation, but it is based on observations and experience. So, what we find that this one, the empirical design, is purely based on the experience of the people, experience of the designers. Similarly, like this, in our later course you will be finding out there are so many other empirical relations developed from the experiments and from the the experiences of the people or the designers, which we call as an empirical design. Now, one of the most important thing also comes into picture is the factors to be considered in machine design. What device or mechanism to be used, okay, to decide the relative arrangement of the constituent elements. Material, forces on the elements, size, shape and space requirement, weight of the product, the method of manufacturing the components and their assembly, how will it operate, reliability and safety aspects, inspectability, maintenance, cost and aesthetic of the design products. So, all these points what has been written over here, let us have a quick recapitulation. In somehow or other this has been spelled in this lecture at the earlier stages, but now let us look into in a categorically. First of all, what device or mechanism to be used? This is a very important aspect, because a same work can be carried out by two different type of mechanisms. So, here comes a decision making, that which mechanism to be adopted. Of course, this which mechanism to be adopted for a better performance. As I have told you earlier, here comes again the same old factor, the decision making. However, the mechanism and thinking of the mechanisms as a whole is a knowledge based, means what I mean to say, that you should have an idea of the what are the different types of mechanism available. Next comes the material. We had a long discussion on this particular material while considering the example of chair. Now, this material selection has become one of the research areas, you can say. Almost the metallurgists are day by day, every day they are giving new materials, new developments. The reason, you know why? Suppose you want to fly an aeroplane, your material should be such that it should withstand the strength, at the same time it should be quite light, the entire machine should be light, so that you have a lesser force to, you require a lesser power to fly the machine in air. Next comes the ideas of the shape, size and space requirements and forces on the elements, weight of the product, and these situations are also to be described. So, we can understand that material, we have discussed force on the elements. There could be various types of force that comes into picture, and this forces could be either a static type of force or it could be a dynamic force as such. So, what we understand is that the next one comes out to be the size. Size is one factor that one has to also consider very carefully. You understand the size, shape and space requirement are again interconnected with material, force on the elements, means these are all interconnected. Suppose you have a material of lesser strength, its sizes increases. Okay? That means choice of material gives you the idea of the size, either oversize or undersize. Another thing is that if you are designing a machine element and following certain standards, then what happens, you know, that this design a size what you get from your calculation, you will use a next size, so that it comes out to be within the standard sizes. A machine what has been designed depends where you are going to use. So, obviously, the space requirement comes into picture, that we can intuitively understand what it is that. Weight of the product, of course, is very much required to be considered, because it determines some the cost onto the product particularly. So, material cost is an tremendous, one thing one should keep in your mind. The method of manufacturing the components and their assembly, that is also very important, in the sense that you can use various procedures we will be discussing, like casting, forging, machining. Which one will give you the same situation is the economics. Better machine, economics comes out to first, and how your design will be withstanding the strength, etc. Of course, you can take up the manufacturing methodologies depending upon the component, but anyway, which gives you a better batch production, which gives you material behavior in a better way. So, all these things are dependent onto the manufacturing technologies. How will it operate? The operation should be very smooth. Just to press a button, a entire system starts. Nowadays, we find in so many machines. Well, that may not be that simple, but still one has to keep in your mind. Reliability and safety aspects, this is one of the situation which has to be taken care of. Now, what is reliability? It is basically a probability that machine will not fail in its life duration. Now, this requires that you have to be very careful that how much wear is taking place, where are the forces taking place onto the machine elements, how it is taking place machine on the machine elements. so that none of the safety norms are being violated. So, that is what is the reliability. So, all safety aspects starting from environment to design strength as a whole should be taken up to make a machine reliable. Inspectability, that means you have to check the machine time to time. So, the machine assembly should be such that you should not have a difficulty in inspectability of the machine. Maintenance, cost and aesthetics of the design products are the this last 3 points have been to be discussed. However, maintenance is indirectly related to reliability and safety aspects. The more and more you have the maintenance, proper maintenance, then some or other your reliability and safety aspects will of course increase in this matter. Cost and aesthetics we have already discussed in this lecture at the earlier case while we were talking about the chair. And so, what we can just very quickly recapitulate the ideas what we have learned in this lecture. Overall, we have learned that machine is a combination of several machine elements arranged to work together as a whole to accomplish specific purposes. Machine design involves designing the elements and arranging them optimally to obtain some useful works. This is what we understand by the machine and machine design as a whole. The steps to be followed by a designer as such: machine design requires a thorough knowledge of engineering science in its totality along with a clear decision making capability. Every designer follows his own methodology based on experience and analysis, that we all know. Next, the main steps to be followed in general are: define the problem. First, you have to be understanding the problem. Make preliminary design decisions, which repeatedly I have told this decision is a very important factor. Make design sketches. Carry out design analysis and optimization. Design the elements for strength and durability. Prepare documentations to be followed for manufacture. The reliability in machine design, this one is the reliability of a designed machine is concerned with the proper functioning of the elements and the machine as a whole, so that the machine does not fail in use within its designed life. Overall safe design approach at every stage of the design is needed. This is the reliability in machine design is a very important factor. So, with this we end the lecture on design philosophy. Thank you.